Hello to everyone. In this video, let us discuss regarding which one 60A group elements. So see here, what are the 60A group elements? Oxygen, sulfur, selenium, tellurium, polonium. Easy to remember, don't worry. How strong Serena tennis play on. So that is easy to remember that 60A group elements. Ho, strong, Serena, tennis play on. Okay, now let us see the atomic numbers of these elements. Oxygen atomic number 8, sulfur 16, selenium 34, tellurium 52, polonium 84. So these are the atomic numbers of 60A group elements. And the general electronic configuration NS2NP4. General configuration. General electronic configuration is NS2NP4. And especially one thing here, these elements are called chalcogens. Why they are called chalcogens means these are mineral forming elements. Mineral forming elements means examples here. Most of the minerals available as oxides or sulfides. Example MnO2 pyrolusite, that is an oxide, and hematite Fe2O3, magnetite Fe3O4. These are oxide minerals. And some minerals are sulfides. Example zinc blend ZnS. Zinc blend formula is what means ZnS, galena PbS. So like that, so many metals available as their oxides and sulfides. So that's why as these are forming minerals known as which one means chalcogens. Okay, now let us see the individual elements, what are the properties and atomicity etc. here. So now oxygen is a diatomic gas. This exists in gaseous state due to the formation of ease of formation of p pi dash p pi bonds. Oxygen exists as a diatomic gas, but the remaining elements are solids in 60A group, and sulfur, selenium, tellurium, these exist as octaatomic elements, octaatomic molecules, but polonium is a which one monoatomic element, and this is radioactive element, and its half-life period is 13.8 days. So this is half-life time. Of course, half-life time 13.8 days, but lifetime is infinity. Okay, now this is radioactive element, and then these oxygen and sulfur, these two are non-metals, and selenium, tellurium are metalloids. These two are which one means metalloids, and polonium is which one? Radioactive metal. So this is regarding metallic and non-metallic character of which one? That 60A group elements. Now let us see that abundance of 60A group elements. So the most abundant element in the earth crust is which one? Oxygen. Not only in 60A group, in entire periodic table, the most abundant element in earth crust is which one? Oxygen. And sulfur is the 16th most abundant element in the earth crust. So now the order of abundance: oxygen greater than sulfur, greater than selenium, greater than tellurium, greater than polonium. So this is which one here? Order of abundance. Okay, then after that let us go for which one here? That properties of that 60A group elements. So the first one is here atomic size. So we know that easily that atomic size increases from top to bottom. And then ionization potential. Ionization potential decreases from oxygen to tellurium. No need to discuss with polonium because that is radioactive element. No need to consider into these general properties. Okay, then but in case of ionization potential, one important question here. If you consider the IP1 for nitrogen and oxygen, IP1 of nitrogen greater than that of oxygen, but second ionization potential of nitrogen less than that of oxygen, because first nitrogen is having which one, half filled configuration, NS2NP3. So due to half filled configuration, nitrogen first ionization potential greater than that of oxygen, whereas oxygen is having which one, incomplete octet configuration. So now here this configuration NS2NP3, but oxygen configuration NS2NP4. So due to half filled, IP1 of nitrogen greater than that of oxygen. But after removal of one electron, this configuration becomes NS2NP2, but this now becomes half filled configuration. So for this reason, second ionization potential of oxygen more than that of which one, nitrogen. So this is, we have to remember regarding which one, ionization potential. Okay, then let us go for electron gain enthalpy, EA1, first electron affinity. So generally what happens, electron affinity decreases from top to bottom, but second element electron affinity greater than that of first element, because due to the compact size, due to the small size of oxygen, in that high electronic repulsion is present. So it is not easily accept electron inside to it. So that's why only that oxygen electron affinity is less than that of which one, all of those elements. So now first electron affinity is having negative value. What is the order? Means sulfur greater than, selenium greater than, tellurium greater than oxygen. And come to second electron affinity. But second electron affinity is positive, because after gaining one electron, now if you try to add another electron, in between negative and negative charges, there is some repulsion. So to overcome that repulsion, now we have to provide some extra energy to that. So that's why only second electron affinity is positive. Now what is that second electron affinity value? Means here oxygen greater than, sulfur greater than, selenium greater than tellurium. So this is regarding which one, electron gain enthalpy values of chalcogens. Okay, then come to observe which one, melting point values. We know that oxygen exists as a gas. That means even we can go for boiling point also. Due to less boiling point only, that exists as a gas at room temperature. So that means here among all those chalcogens, oxygen is having less melting point. So now what is the order here? Oxygen less than, sulfur less than, selenium less than, polonium less than tellurium. So highest melting point possessed by tellurium, least melting point possessed by oxygen. Now come to the boiling point order. Oxygen less than, sulfur less than, selenium less than, tellurium less than polonium. So highest boiling point possessed by which one? Means polonium. So these are regarding which one, melting and boiling point values, electron affinity values. Now come to electronegativity. So electronegativity decreases from top to bottom. That means oxygen greater than, sulfur greater than, selenium greater than, tellurium greater than polonium. So these are some general properties of which one, that chalcogens. Okay, thereafter Let us go for which one here? Oxidation states of chalcogens, that means 6th group elements. So what are the common oxidation states? Let us see here. Common oxidation state is which one? -2, because due to that NS2 NP4 configuration, by gaining 2 electrons they get into octet configuration. So common oxidation state is -2, and in ground state these exhibit which one? -2 and +2 oxidation state due to the presence of 2 unpaired electrons. In ground state they might loses these 2 electrons, so +2, and by gaining 2 electrons they exhibit -2. In first excited state, this p orbital electron migrate into which one? Excite into d orbital. Now due to the presence of 4 unpaired electrons in this first excited state, this can exhibit which oxidation number? Means +4. Okay, now let us see the second excited state. In second excited state, this s orbital electron also excite into d orbital. Now due to the presence of 6 unpaired electrons, now the oxidation number is how much? Means +6. So like this here, common oxidation numbers we can take -2 and +2, but in first excited state exhibit +4, in second excited state they exhibit +6 oxidation state. And oxygen has some special oxidation states. What are the special oxidation states? Let us see here. Oxygen common oxidation state is -2, but in peroxides oxygen exhibits -1 oxidation state. In superoxides means example KO2. In KO2, what is the oxidation state of oxygen? Means -1/2. When it combined with fluorine, oxygen exhibit positive oxidation states. In OF2, oxygen exhibits +2 oxidation states. In O2F2, oxygen exhibits +1 oxidation state. Of course, in elemental state, that oxidation number is 0. So these are the different oxidation states of which one? Oxygen. Okay, this is regarding oxidation numbers of 6th group elements. Okay, then let us go for allotropy. Allotropy means we know that existence of an element in 2 or more than 2 physical forms having same chemical properties but with different physical properties, known as which one? Allotropy. So now oxygen has 2 allotropes. One is diatomic oxygen, one is triatomic ozone. Diatomic oxygen is paramagnetic in nature according to MOT, molecular orbital theory, and ozone is diamagnetic in nature. So this is regarding allotropes of oxygen. And in 6th group, sulfur has more number of allotropes. So what are the allotropes? Let us see here. Sulfur, the first allotrope of sulfur is, what is that first one? Rhombic sulfur or octahedral sulfur. Rhombic sulfur, and it is also known as octahedral sulfur or alpha sulfur. So now this is having pale yellow color. What is the color of this sulfur? Means pale yellow color, and it has octahedral shape with S8 molecular formula. So that's why only it is known as which one? Octahedral sulfur. And the second one is monoclinic sulfur, monoclinic or prismatic sulfur or beta sulfur. Okay, this is also having S8 puckered ring structure, or we can say these are having crown type of structure, both of these. That is called puckered ring or crown structure. Okay, now beta sulfur is stable about which one? Stable above that 369 Kelvin temperature. So alpha sulfur and beta sulfur present in equilibrium at 369 Kelvin. So above 369 Kelvin beta sulfur is stable. Below to 369 Kelvin alpha sulfur is stable. And another form also there, gamma sulfur. Alpha, beta, gamma, all these three are having puckered ring or crown S8 molecular structure. Okay, then, and above that, for example, if you eat up to 160 degrees centigrade, now due to the cleavation of which one here, that chain structure, due to the cleavation of that chain structure, and that dissociates into which one here, S6, S4, S2, like that. And at elevated temperature, that means at 1000 degrees centigrade, this S8 converts into S2, and it is also having paramagnetic nature as which one? Oxygen. So this is regarding which one? Allotropy of chalcogens or 6th A group elements. Okay, then let us go for which one here? Chemical properties of 6th A group elements. So chemical properties, in that first, let us go for oxides, that means hydrides of 6th A group elements. So hydrides of 6th A group elements, what is the formula means here? H2M, where M is chalcogen or 6th A group element. So examples what are here? H2O, H2S, H2Se, H2Te. Enough. No need to write H2PO now. Up to here enough. So these are the 6th A group hydrides. So H2O known as which one? We know that water or hydrogen oxide. And H2S is hydrogen sulfide. H2Se hydrogen selenite. H2Te is hydrogen telluride. Now let us see the formation, preparation, that means preparation, ease of formation, properties of these hydrides. So first let us see the preparation. Preparation means here very simple, by the direct combination of that hydrogen and 6th A group elements, one can prepare which one means that 6th A group hydrides. But ease of formation decreases from H2O to H2Te. Ease of formation decreases. And come to stability. Stability also what happens? Decreases. Stability also decreases from H2O to H2Te. And then bond length, M-H bond length, that bond length increases from H2O to H2Te. Bond length what happens means increases. Okay, then come to the bond angle. Bond angle decreases from H2O to H2Te. So one important thing we have to learn here. What is the important thing? See here. In H2O, oxygen sp3 hybridized, and due to the presence of two lone pair of electrons, bond angle decreases to 104 degrees to 28 minutes. But in case of remaining hydrides, the bond angle is approximately near to 91 degrees. So what is the reason for this bond angle means? In case of remaining hydrides of chalcogens, the central atom uses pure p orbitals for bonding, no sp3 hybridization. So sulfur, selenium, tellurium, uses pure p orbitals for the bond formation with hydrogen atoms. So we know that the p orbitals px, py, pz are perpendicular to one another. That means the angle among the three orbitals, we know that how much, 90 degrees. So that's why only in remaining hydrides of 6th A group elements, the bond angle is near to 91 degrees. That means near to 90 degrees. So this is regarding which one? Bond angle of 6th A group hydrides. Okay, then after that another property here, what is that? H2O is which one? Liquid, but H2S present in which one? Gaseous state. What is the reason? We can get this question also. Why H2O exists as a liquid but H2S exists as a gas? What is the reason here? Due to the molecular association through intermolecular hydrogen bonding, H2O exists as a liquid, but due to the absence of such type of association, H2S exists as a gas, and H2S is having rotten egg smell, and that is poisonous gas. But H2O is colorless, odorless, tasteless liquid. Okay, then after that we have to see which one? Acidic character. Acidic character of 6th A group hydrides. We know that H2O is, even the people are drinking that. That means H2O is not having any acidic nature now. So that is neutral in nature. So like that, H2O acidic nature less than, H2S less than, H2Se less than, H2Te. And we can get another question also. What is the order of Ke? Ka value. Ka means acid dissociation constant. Same order we can give. H2O less than, H2S less than, H2Se less than, H2Te. But order of P power Ka value means we have to make it reverse. We have to make it reverse. Okay, then come to know boiling point order. So what is the order of boiling points? So generally, as molecular weight increases, that boiling point values also increases. That means here H2O should have least boiling point, H2Te should have highest boiling point. But due to the presence of intermolecular hydrogen bonds, H2O dominates over H2Te also. That means what is order of boiling point here? H2O greater than, H2Te greater than, H2Se greater than H2S. And what is the order of volatility? Which can easily volatile? The compound which is having least boiling point, that easily what happens? Evaporates, volatile. So that means what is the volatility order? Means H2S greater than, H2Se greater than, H2Te greater than H2O. So this is the order of volatility. And what is the structure of 6th A group hydrides? In 6th A group hydrides, the central atom undergoes sp3 hybridization and having two lone pair of electrons, and due to that it is having which structure? Means pyramidal structure. So these are the things regarding which one? Hydrides of 6th A group elements. Okay, in our next video let us go for which one? That oxides of 6th A group elements. Okay.